Yes, good afternoon, everyone. Welcome to this is part of the series we are running under the geophysical excellence. It's a pleasure today to introduce Dr. Aditya Mishra. He has just a week or so joined us as a postdoctoral scientist. Before coming here, he was a scientist at the Wadia Institute of Himalayan Geology, right, at Dehradun. He has extensive experience doing field campaigns on various glacier sites in the Himalayas. He's going to tell us a little about some of his research from his PhD days up till now on this Himalayan field campaigns.
Thank you. Thank you, Mani sir. So, first of all, I would like to thank Mani sir and all for being here. Myself, I introduce myself first, and this is as yes. So, I'm Aditya Mishra. I did my PhD from HNB Gadwal University, Uttarakhand, and so after doing PhD, I joined Badi Institute, and I was doing glaciology there for a couple of months, and after that, I joined this institute. So my today's my talk on the dynamics of Himalayan glaciers and their response to climatic and non-climatic parameters. So as we know that, from this picture itself, I will start with this picture itself. So you can see one of the peak covered by the ice, and so you might be assume that this is the glacier. So I think you are assuming the glaciers like this, having the beautiful white ice. So, but it is not the exact Senso Stricto glacier. This is a just mountain peak covered by the snow and ice. So it is named as a peak named as a Nilkant, having it has height of about 6,500. You can see from different sites. It is visible from the Badrinath also, from different from Josimat, from all the sites around this town, Badrinath town or all. But this is not exactly glacier. So glacier are some different than the this snow-covered peaks. So what is exactly the glacier? What we are dealing with basically the valley glaciers. Valley glaciers, which follows the mountain valleys, and they start from the head wall, then they down continues to down, and then they have terminate at a certain point. So that is the is there any point? No, no, no. Okay, so
Can you use the mouse?
cursor.
The cursor?
Okay, sure. So
If it's more comfortable for you to sit, you can sit there.
I think yes. I yes, thank you. Thank you. So so there is a glacier. There is a glacier. So in valley glaciers are different than the others. This alpine, the continental and other glaciers. So this start from the head wall and then it terminates near the snout, and but they are not very clean glaciers as we have seen in the pictures that they are very clean and look like blue eyes. So they are covered by the certain things, rocks, stones, and mud, and these rock and stone and these are called as a debris cover. So Himalayan glaciers, many of the Himalayan glaciers, particularly central Himalayan glaciers, are covered by the debris. So you can look at this picture, so that there is a this debris underneath, ice is there. So the glaciers are, if you are assuming that there white ice patch or snow is there, so glacier might be there. So it is not the case. This is the just peak. This is Chokamba Peak, from where this valley glacier starts. This is the Satopan glacier, beautiful picture of this glacier. So accumulation, and the for ice, for any ice to be glacier, it must have a certain size, shape, and it also has accumulation and ablution zone. From so means there are different parts of glacier. So in accumulation zone, the glacier accumulates ice from all the ways, or from avalanching, or from avalanche, mainly from the avalanching and from the snowfall. While the in the ablution zone, that is this zone which is covered by the rocks or stones, and that is ablution zone, and from there, this ice melt mainly by different parts. Means from the surface or in glacier or supra glacier, means above the glacier, or some there are channels in glacier. So there are different ways, so that so glacier melting, from which glacier melting takes place. So there, this is a schematic diagram that shows how glacier or valley glaciers are. So this is the world eye view of the Himalayan valley glacier, and this is the cross sectional view. So this cross sectional view indicate that this there are two parts: accumulation zone and ablation zone. Accumulation is just where the mass accumulates, and this ablation where mass ablates. So this defines the accumulation, and ablation defines the response of glaciers to any climatic change. If there is a any climatic changes in the region, so if it means changes, if positive changes, then it ice ablation will be more, and this will accumulation will be less, and so overall glacier will recede. It will lose mass higher than that of the its accumulation. So the changes will be visible in the glaciers at their terminus in the frontal part by change in their length, and also the thickness, and surface lowering will also be seen if this melting will be higher than that of accumulation zone. So this is schematic, and this is the line. This is there is an imaginary line which separates the accumulation and the ablation. That is called accumulation equilibrium line altitude. Equilibrium line and the altitude at which it lies, that is called as equilibrium line altitude, ELA. So ELA is suppose where the mass balance is zero, and in the accumulation zone mass is positive, while the in the ablation zone ice mass is always negative. So this is the some this is the means you can say the overview of the valley glacier. So where these glaciers are distributed means worldwide, and what is, so you can see this is the world map. So mainly glaciers are concentrated on the poles, Antarctica and Arctic, but away from these polar regions, most of the ice lies in the high mountain Asia, that is the Himalayan region. So that's why this is called as, so this is the Himalayan region. So there is an organization, World Global Monitoring System, that has categorized the whole world into different zones, and this is the so they have grouped into different based on the type of glaciers and continents. So high mountain, these are characterized as the high mountain glaciers. I think you have to share the again. You could share only this video, right? When you share the entire screen, and then to go to the presentation.
Is it okay now?
Is it okay?
Yeah. Okay.
So the most of the glaciers are concentrated, and so that's why it is called as the third pole. Apart from, because Arctic and Antarctic, the maximum ice lies in the. So this is the main reason where we are concentrating. And so why these glaciers are important worldwide? So they are the best, means they are the freshwater resources. They are means they are providing waters to the mainly perennial rivers throughout the year. But for this reason, particularly for high mountain Asia, these rivers are very these water towers, means these glaciers are under threatened because of the climate change, and the population density, means highest population density is in the Indo-Gangetic plain. So the river Ganga has the highest water tower index. This thing vulnerability to the climate change. So this is a paper, very good paper in Nature, came in 2019. So before that, they have also published paper after IPCC report 2009. They have also said that the climate change will affect the Asian water towers. They have in that paper, particular paper, they have talked about the Himalayan this high mountain Asian glaciers, but this paper highlights the importance of overall world glaciers. So, in this point of view, so they have pointed out clearly that this high mountain Asia is highly vulnerable to climate change. So water, because of the population density, and they have taken certain other parameters, climate change, and the this install hydropower projects. In all the context, they have they have come at the conclusion that this is the highly threatening region. Water tower is any means this glacier means water tower means water concentration of ice is called as the water tower of high mountain Himalayan region. Water tower on the earth, apart from the polar regions. So this is the reason where we are focusing particularly. So Himalayan and Karakoram region. So the glaciers, this region have been divided into three parts, basically central, eastern, and western. So some people categorize Karakoram as separate, but some takes consider it with the western Himalayan region. So we take at a separate. So the climatic regimes, if we look for the, so the Karakoram and western Himalaya region receive maximum precipitation during the during the from in winters during the westerlies, and the central Himalayan and eastern Himalaya receive maximum precipitation during the Indian summer monsoon, so mainly July and August, June, July, and August. So in the terms of area, so maximum area coverage, glacier area coverage in the Karakoram range, followed by Western Himalaya, Central Himalaya, and the least in the Eastern Himalaya. And in terms of volume, so because area and volume are more or related to each other, so this also Karakoram range also have the highest volume of glacier ice. So water reserves are maximum available in the Karakoram region. So, when we come at the glacier area, so Himalayan in the Himalayan Karakoram, they have almost equal glacier glaciarized area. These are in kilometers square. So, yes. So, different authors have mapped glaciers of Himalayan and Karakoram region with the help of remote sensing data. So, this is the first, you can say, after before this. The people means researchers were used to were using the topographic maps for glacier extent. So this was the first glacier inventory which have been prepared by Kogle and these things. Then they have revised. But if you will look, if you look at the numbers, so there is a difference, large difference between all these data sets. So this is my one of my problem I will be discussing about. So why there is a large number? There is a area. Yes, but there is a huge difference. So uncertainties in glacialized area is different. So this may be because of some reasons. So, but with the advent of this remote sensing technology in satellite images on all these things, so they have mapped the glaciers to a great extent. So
These are different years, right?
these are different images are from same years, almost from same years, but the authors have done in different years.
Okay, so the data is from the same year.
Almost for the same years, yes, plus minus 3 years.
And season?
Season is almost for the glacier mapping. Images are used mainly for the late abrasion season, because that during that time glacier are exposed. Glaciers are free from the snow. So they are, so snow and glacier are different. So all the snow patches are not glaciers. Glaciers are perennial ice that have survived for many years. And whereas snowfall just after winter, you can see snow even at the lower altitude. So they are not glaciers. That's why that was the aim to show that first slide.
Snow and ice, how are they different?
Snow and ice are different. They convert snow glacier start forming from snow. So continuous snowfall will convert into the fund by continuously density, means converting compression. So snow has the density of around 300 cubic kilogram per meter cube, and then it converts into the ice, and which has the density of around 900 kilometers.
Remote sensing, how do they show?
In remote sensing, there are spectral signatures that take into account for glacial mapping. So another the this so coming to the directly on this particularly on the Himalayan Karakoram region. So this is the paper in the science last before last year, I think. Yes. So they have shown that how the glacier melting is affecting glacier contribution in the rivers. So there are different basins: Indus, Ganga, and Brahmaputra. These are three different river basins and perennial river basins. So they have shown that the contribution of glacier melt water is maximum in the western and Karakoram Himalayan region, while the central Himalayan and eastern Himalayan rivers are mainly fed by the precipitation. So contribution is very less, as you can see here. Also, this is very about 25% only from the glacier, while here about 80 about 94% from the glaciers. And glacier means glacier and snow, because melt contribution always combined in the form of snow and ice. So this is important. Means glaciers are important for large basins like Indus Danpur, but these are also important for a small basins or catchments where only glaciers. So this is the study it is under preparation, under review. Paper is under review. So what we have done, there is a catchment is Virahi Ganga. So there is a only single glacier in the catchment, and so this catchment has the area of about 300 kilometers square, and the out of it only 1% is covered by the permanent snow. So this and about 10,000 people live in this basin, and mainly along the so what will so if there is if the glacier is continuously changing, it will influence the this river flow. And they have also constructed the dam, very small dam, but 7.2 megawatt. So it will also means changes in glacier will also affect this water to the this dam also. So this is the glacier, and the very interesting thing has been noticed that this glacier has been fragmented into two parts: the lower one and the upper one. The upper one is now directly this the lower part has been detached. So now its snout has been shifted upward. So this is another situation. There may another possibility to there may be a chance of collapsing of this glacier ice due to the steep slope, and there are many crevasses. So this is the sort of paper which we are doing. So this is, and the region is also very vulnerable to disasters. So this Virhi Ganga catchment has witnessed lot of disasters in the past. So in 1884 there was a flood from the near this Gohna, and the lake was constructed, and then it breached, and suddenly then it washed away most of the things in its way up to the Haridwar. So about 200 kilometer downstream. And then in 2021 there is a very I think phenomenon disaster occurred in Rishi Ganga catchment. So this is the peak, that is Rothi peak. So this is sharing the boundary with this Rothi Rishi Ganga catchment. So from the water importance of glaciers for water in the river basins, from apart from this, these are also important for hydropower sectors. So because these rivers are perennial and flow throughout the year, so they have constructed large dam on this river basin. So if there is any change in glaciers, they will also affect the river runoff, and then ultimately to the hydropower projects. So in Indus, this is Indus. I have this made this Ganga and Brahmaputra together. So Indus have the installed capacity of around 14,000 megawatt, while Ganga 5,000, and about 4,000 in Eastern. So they have also lot. This is the potential hydropower generation, means potentially available source in this basin. So they are potentially very means important for hydropower sectors. So from water resources, hydropower generation, they are also influencing the human lives human lives, who they are the people who are living in the mountainous region. They are creating lot of problem, and they are posing many threats to them. So glacier have many hazards, like avalanches are very common, but they don't directly affect the people because they are sometimes they occur or in the remote areas where people are not there. But the blocks, glacier lake outburst floods are very common, so they affect the downstream areas and even far from the source. So this is there are many examples, so I will discuss I will only tell about two examples so that have cast the means media coverage worldwide. So one is the Kedarnath disaster and another is the Kedarnath disaster occurred in 2013. So there was a lake called Chorabari Lake that breezed, that is very close to Chorabari Glacier. That so a continuous rainfall of 3 days. So it was filled and breached from here, and then it devastated the downstream areas, Kedarnath and its downstream areas, and around overall 6,000 people lost their life in this disaster. Overall, from Kedarnath to Sonprayag, from all the way, not only in the Kedarnath. So 6,000 people lost their lives. So it was related to glacier related hazard. So another phenomena occurred, and a unique phenomena occurred in 2021 on 7th February. Normally, when a glacier collapsed along with rocks, and then fall on the floor from about 5,800 meter, and then it devastated the downstream valley. So there is a place called Tapovan, 15 kilometer from Josimat, and their people means workers were under tunnel. So this tunnel was under construction, and then 200 people lost their life. So these glaciers are also very important for hazard point of view. So we can, if we study properly the glaciers, so we can reduce the loss life from the glaciers. So there are also many examples I can give, but for time being, there are these two examples. So one I will also mention another example from avalanching. So in avalanching, last year in 2022, avalanche occurred on the Dogriani Glacier, which is very famous and famous in terms where the field studies are being carried out from 90s or 1995. So a mountaineering group from all over India, they went there and they come in under this avalanche, and 28 people lost their life. So these are also means there are glaciers are also important for their this related to hazards. So now coming to after this hazards importance of glaciers for their different purposes. So what is happening with the Himalayan glaciers? What is the present state of glaciers and how they are behaving? So there are because earlier we don't have the much data about the glaciers. So and over the time due to the advancement in the satellite data and all these things, so a study came in 2019 that say that glaciers are retreating, are shrinking, means shrinking means thinning, in losing their mass more than that of their previous decade. So the rate of change is almost twice in 21st century as compared to the past few decades during 1975 to 2002. No, sorry, 2000. So the rate, so they have also the means highlighted that the glaciers which are terminating into the lakes, they are melting faster than the other glaciers that which are land terminating. So overall, the glaciers are shrinking. So there are some glaciers which are gaining mass, but they are in the other side or in the Karakoram or somewhere in the Pamir side, not in the Himalayan. So most of the glaciers are in the shrinking phase. So they have so meter water equivalent. So ice is converted into the water, multiplying it means thickness change is multiplied by density of ice. So to get melting in terms of water. So because the ice has been melting in terms of water only.
The different color dots.
Yes, dots. So the red dots indicating the glaciers which are ending in the lakes, means having the lakes at their mouth, and the blue ones are the normal clean glaciers, means those who doesn't have, the glacier doesn't have the rock and stones over it, and the dot this dot one these are the having the debris, rock and stones over it. So three different type of glaciers they have, means but the blue one are these are, this yellow line is the general one. So they have categorized the glaciers into different, three different, mean clean ice glacier, debris covered ice, and lake terminating glaciers. No, glaciers are not increasing, they are losing, all are losing mass, but at different rate.
If I can see the latitude line near about 85.
Yes.
So I'm speaking.
Yes.
The density of blue dots are more compared
So,
to that.
so that may be due to the yes. Here you can see there are very means limited, and then so this and then you will see the number of glacier increase. So before, from 1975 to 2000 there was data scarcity, so they have taken limited number of samples, whereas in this case after 2000 they have increased the number of samples. So no, but they have, for this conversion, for this mass balance, they have taken to it is yes, ideally it is not same, but for this conversion they have taken it uniform at about 850 this gram per meter cube.
This is a combination of in situ measurements.
No, this is just basically based on the remote sensing data, nothing, no field studies.
Density of ice, the number density of this.
So
Density of ice.
okay. So may I go ahead? Yes. So they have yes, it is entirely. So this is from the hexagon images, which is available from that spy. I have time. Do you? So that I have to quick. So I can discuss this thing later also. So yes. So they have attributed this glacier changes, means highly this rate of increase in glacier after 2000 due to the climate change. So this is the report from MOES came in 2020. So they reported that the Himalayan region is warming as a higher rate than that rest of the Indian region, and that this warming is also elevation dependent. The elevation means the higher region are regions are warming faster rate than that of the lower regions. So trend is not uniform, but this is the increasing trend of course. So this is mainly, they have very limited data sets. They have IMD data set. They have very limited stations across the Himalaya also. So there, that's why. But there all the stations are recording the warming temperature. So the changes in glaciers are mainly attributed to the change in climatic conditions. So this is the case also with, so from I study from ISER Bhopal, they have come with the that the mass balance is the response of snowfall. So they have correlated well they have correlated the mass balance with the snowfall pattern, and they found that they are well correlated. So mass balance snowfall dictates the mass balance in the Himalayan region. So this region receives maximum snowfall because of the western disturbances. So the mass so that's why the glaciers are not losing much rate mass at a higher rate, while this region is not have that much of snowfall, so they are losing their mass at a higher rate. So from western to eastern, from western side to eastern side, the glaciers are continuously the rate of change is continuously increase. So, the glaciers are losing mass by thinning. They also, because of their response, they also change their frontal part by changing their length and area. So length is so one of the study, they have combined all the glacier changes in area and length. Then they found that the glaciers are these changes are very heterogeneous. From they are variable from about uh, about 80 meter per year to about 60 meter plus. 60 meter plus means from in they are gaining length. So so that is the different condition. So I will be discussing this. So the rate of glacier length is variable, highly variable, and so they have the average according to basin, and found that the glaciers in the Indus Basin are retreating at 12 meter, about 13 meter per year, 15 meter and 20 meter in the west, in the eastern Himalayan region. So this is the point that you might, so it is gaining length or it is not retreating. So this kind of glaciers are surging glaciers. So this kind of glaciers are common in the Karakoram or western Himalayan region. So they are not, so they flow downstream. Glaciers, complete ice body, flow downwards due to certain conditions, climatic and topographic conditions. So this is means surging. This kind of glaciers are surging glaciers, not the normal glacier. And that's I will also discuss. I think some Karakoram. That's the Karakoram glaciers have not. They are in the stable condition. They are not gaining, not losing mass as that of this central Himalayan or eastern Himalayan glacier and even western Himalayan glacier. So the Karakoram glaciers and this Pamir and Kunlunsa glacier that is in also in the Pamir. So they are not, they are under either stable condition or they are in slight advanced condition, either not losing mass. And this is continuous since 1975. From that study, the previous slide also indicate the consistency in the data.
I have a question.
Yes.
You were saying that this gain is increasing. Right?
Sorry.
Glaciers are surging.
Yes. So all are not surging. Only the reason which is the glaciers which are concentrated around this Karakoram, they are surging. Not all the glaciers. The basin is a very large basin, so all the glaciers are not surging. Even the Himachal glaciers are also contributing in the Indus River. So, but this they are not surging. They are losing mass. So there is a peak or region that is Karakoram and Pamir and Kunlunsa. So the region there, the glaciers located around it, they are they are not losing mass.
Those are stable, others are like
Yeah, yes, yes.
getting or like changing.
So those are increasing and they are not changing, both the things, and the others are losing mass.
Fine.
So this is not the mass. This is about the glacial length. They are their frontal position. So I as the mass, the thinning. There are three components that are continuously monitored, and the changes which are visible in the glacier dynamics. So thinning, vertical thinning, and the frontal part, that and their frontal area. So these are the visible changes. So now I'm talking. There are lot of processes and lot of the means, so that can be that can say that the glacier is changing, but these are the three very visible visible to anyone, means by no added means is needed to look for them, the changes.
Bottom parameters for an area change.
Yes, right. So there is so in the area changes, so these glaciers are also near stable conditions, while some glaciers are the changing at a higher rate, while the in the Brahmaputra basin the rate of area change are considerably higher. So if we look at the numbers, so this is almost in the Brahmaputra basin, the glaciers are retreating, means area changes are relatively higher, just double. So now the only if the glaciers, yes. Now the question is if the yes. Now I will come. I think I will later. So now the if the glacier climate is the only parameter, so changes should be there in the uniform. So but the changes in the glacier area, length, and its mass are heterogeneous across the region. So there is another driving forces that are regulating the glacier dynamics. So what are apart from the climate, what are those parameters? Those are influencing the glacier response. So that's why that is the point that I will be discussing. So now come at the, so all these studies I have mentioned here all based on the remote sensing data. So now only there are few field-based studies where the glacier monitor has been monitored in the field. So some of the from 1975, but these were concentrated in the these were conducted by the Geological Survey of India, Kolkata. Its head office is in Kolkata, and I think they have done from Lucknow. So only limited glaciers were there. So in from 1990 and 2000, there was very rare. Only 2 or 3 glaciers have been but the number have increased. But out of in Himalayan region there are 10,000 glaciers. But after 10,000, only 15 or 15 because in some of glaciers are here in also from Nepal. So only 15 glaciers have been continuously monitored, and not continuously, they have been monitored in the field, and the continuous data is limited for only four glaciers, for Chota Sigri Glacier, Dokriani, Chorabari, and to some extent Satopan, but we have not published, so it is not included here. So there are only limited glaciers which have the decadal data for a decade. So now number of are of course increasing. So why these means having this large glacier extent in the Himalaya, and when why only 10 glaciers have been studied? So there are a lot of things, there are a lot of challenges. I think the trained people, accessibility, approach. So these are the certain some field challenges I am showing here. So when we were going to field, so there was a bridge we have made with the help of this bamboo sticks. This, and then when we were coming back, and it was the way. So we crossed this glacier, this stream, by just going into the water, and then we crossed it. And so these are the potters, we are helping them to come out from the river. So when during the night it was snowfall, and then it completely this tent buried under the snow. And then so we were all the night, means wake up and then cleaning our tent. So this is the just condition. So there are a lot of difficulties, and so there is snowfall in Badrinath, and then all the things stuck, and we stuck for even week, and we neither we can go up or nor we can go come down. So we were stuck there for a week. So this is from 2018, and it was my, I think, third year of PhD. So it was very scary, this thing. So it happened in Himalayas. So these are the things, I suppose. So, and the field is, apart from this, funding is also important, because the field work in the Himalayan region is also cost effective, costly. Yes. Actually, yes, I think so. That is you have to. So now this was all the background. So I have given about the Himalayan glaciers, their state, how they are changing. So now the work which on which we are focusing. So we are mainly focusing on one basin, particular basin, and particularly one glacier. So we are trying to combine remote sensing data with the field data, and we are trying to. We know the glaciers are changing, we know the retreat rates and all these things, but we are trying to improve the retreat, improve the area and mass and all these things, all the dynamic parameters with the help of field inputs. So this is our, so though this is Alaknanda, Upper Alaknanda Basin, which is located in the Uttarakhand state, Chamoli district. So Alaknanda River emerges from the Satopan Glacier and come to the Vishnu Prayag, and it joins by another river that is called Dhauli Ganga. And there is another major stream that is called Saraswati, and it comes from the near this Tibet Pass, and joins the Saraswati, this Alaknanda at Mana. So this star indicates the Satopan location of Satopan Glacier, where we do our field measurements. So from Mana we have to go by track to reach there, about 10 to 15 kilometers. So this is the Satopan Glacier, where we have performed our this field-based measurements. So this is the, so what we have done, already we know that the glacier are changing. So for this particular basin, there was no up to date glacier inventory. There was no area change after 2006, and the glacier changes were only sporadic. For Satopant, Nanval has done some work, Dhamri has some done has some work on the sporadic glaciers for from 1968. But from 2006 onward till 2020, there was no study. So we have taken this as a whole, and then what are the, and try to understand what are the factors that are regulating this glacier area and length changes with the help of field data. So this basin receives mainly precipitation during the July and August. And the temperature is very highly variable from winters from January to this July and August. So both months are almost same receive similar temperature, means observe similar temperature and precipitation. Now the problem is why, just I have in my previous slide, in the introductory slides, so I have shown that are glaciers different in glacier area. So why there is different in glacier area? So if the glaciers are clean, if glaciers are clean like this, so there is no problem to map the glacier. If the glacier like this, so there is a lot of difficulties to map the glacier. So where is the glacier front, where is the snout, and where is the accumulation zone? So that's why there is a large uncertainties in the glacier mapping. So what we have done in this study, we have used different remote sensing data and used our field studies to map the glaciers of the upper Alaknanda basin. So for all the glaciers, we have not done we have not visited the all the glaciers of basin, but from Satopant and Bhagirath Khada glacier, so we have taken them as an ideal, and then the same criteria has been used for other glaciers also. So the one problem in 1962, there is a topographic map, and they have marked these two glacier, Satopant and Bhagirath Khada glacier, as one glacier. This line. So, but we know that these glaciers are different, and so Nanwal has done revised his earlier paper. They have mapped. They have gone through the historical records available with GSI. They have shown that these glaciers have two different snouts, so that on the basis they have demarcated that glaciers have different they were different even before 1962. So it is not possible in 1958 the glaciers were different, and then 1962 they have joined, means they gained mass and they joined in the short period. It may be possible, but in the during only 4 years it is not possible. So they come at the point that the glacier mapping in the topographic map is problematic, because they cannot separate the debris covered ice, like here they cannot the debris covered ice and the clean ice. So that's why they have make the problem make this error. So they come up with the idea that where there is a sudden change in glacier, so there is a if because the sudden change in glacier give rise means give in direct indication of glacier starting point of glacier. So they have so that's why they revised the glacier boundaries based on this. So they said that the glacier boundaries are inconsistent in topographic maps, and but their elevation points are accurate. So these are the maps which were used earlier by GSI and all these agencies to map the glaciers of Himalaya. So that's why there are large of uncertainties in glacier area. So after mapping, so we have done a lot of field work around Satopant and Bhagirath Khada glacier. So we mapped with the help of digital differential GPS around its snout region and around its boundary. And so people normally in the remote sensing data and in the remote sensing data, either it is high resolution, they miss all these things, the small things. So that these are the dead ice mounts. So dead ice mounts are those which have disconnected from the main glacier body that is moving, but these are the isolated and then have become stagnant. So this is possible only with the field studies. So there is a clear cut indication that there is a slope, this glacier is terminating here, but it is not possible to capture all these things in the remote sensing imageries, whether it is very high resolution or whether it is miss resolution of having lands at 30 or 15-meter resolution. So we have also find out there is a dead ice in the front of this Bhagirath Khada glacier. So this is possible with the field. So this is the importance of field studies, how the glacier front mapping can be improved by incorporating the field service. So these are some field photographs indicate the some this geomorphologic feature, glaciologic features around the Satopan. So this is the snout. So this is the lateral moraine, and this is the trim line. This is the maximum extent where glacier was in the past. Few means 1,000 year back, I think around 60,000 year back. So these are the hanging valleys. This is the peak which I have shown in my first slide, the Nilkant peak. So this is not the glacier, but of course this is the glacier that is because this is just ice apron. This is the hanging glacier. I think now I think is it clear?
Yeah.
Yeah. So this is the glacier. So people also so why there is a difference again? So people also sometimes they take this as a glacier and sometimes they don't take. So there is no uniformity in glacier mapping. So we are trying to improve glacier mapping with the help of field inputs. So this is also the Sotopan glacier. Oh, just no. I think scale. Scale. Actually, this photograph is just taken from the phone. So no scale, but this is the of course 1.2 meter. This rod. Yes, yes. So cannot give. But it is. I think the yes. I can. I can. 10. Yes, yes. Because the cliff is around 20 meter. So and the height of this is around 30 meter, even more than that. So this is around 40 meters. And this is not. This is 5 or 10 meters only. So yes, this is of course 40 meter from here to here. This is slant, but the vertical thickness is about 40 meters. So we have done also GPR survey here. Yes. So when glacier, sorry. No, this is the geomorphic expression of the glacier. So these lateral moraines are higher than that of the main glaciers. So these are actually these are ridge-like features. So it is clearly distinguishable in the field and even in the maps also. So even you, sorry, year. For year, this chronological data is needed, but some dates have already been done by my supervisor in this area. So on the basis of that, I'm telling that this may be from 60,000 years back. Not done. They have not dated. They have not found any sample from 60 years back, 60,000 years back. But they have got samples from LGM. Yes, very close to this. Yes, very close to this. They have found 5,000 years. But this, I was talking about this TL that is around 60,000 because these are most probably formed during the when glacier was maximum, their maximum instance, and it was during MIS, marine isotopic stage. It was around 60,000 years back.
So this is 60,000 with a guess.
Yes, it is guess. Yes, it is guess. Yes, but based on the some dates, not in this valley, but from other parts of the Himalaya. So, what now we have done, we have come at the point that where glacier is frontal is mapped in the remote sensing images and in the field. So we have clubbed all these our points, means field based points in the remote sensing data, so that we have we could able to means mark the uncertainty, means difference between these two in the remote sensing data and in the field data. So that is standard. We have propagated these uncertainty for all the glaciers of the basin because the this has been done by me. So the it is assumed that the if user is same one glacier, so it the similar errors will be there in the for other glaciers also. So after mapping means after mapping the glaciers of the basin, so we have categorized them according to their morphology. This is modified, slightly modified after the GLEMS standard. So we have classified glaciers into simple basin where there is no tributary and nothing, only a trunk glacier and there its accumulation. Then there are surge glaciers. So the surge glaciers have mainly these are clean and they receive they have accumulation and they have amphitheater like some bowl like depression where glaciers accumulate, and there are this compound valley glaciers. Compound valley glacier, when there are large number of tributaries join the main trunk of the glacier. So this is one of the glacier in the Saraswati Valley, means part of this Alaknanda. So there is a this compound valley glacier. Then there are mountain glaciers. These are simple, just clean glacier that follows the mountain slope. So we have classified them as a mountain glacier. Then these are the hanging glaciers. So hanging glaciers are very steep and also follows the this mountain slope. So this is the one field photograph that shows the how hanging glacier look like. So based on this mapping and the classification, we have finally come we have come at the we have come at the result that the glacier, there are a large number of glaciers, about 200 glaciers in the upper Alaknanda basin, having different size and having different morphology. So most of the glaciers are small in basin, smaller in size, while the large glaciers are mainly compound valley glacier. So compound valley glacier, the hanging glaciers are also larger in number, but there are the area is less as compared to the compound glaciers or simple glaciers. So simple glaciers are very about 30, 31 in this basin, and while the large compound glaciers are 10. So this is the just characteristic of UAV glaciers. So the smaller glaciers are more, and these glaciers are having the less steep slopes, while the larger glaciers are less in number. They have the higher this gentle slopes, and they are mainly compound type glaciers. So this is the, and then simple glaciers and all these things, all the glaciers are there. So there is also altitude-wise distribution. So most of the glaciers are located around their maximum area lies in the range of about 5,600 meters, and the debris-covered glaciers have their area at two different peaks around 5,100 or something, and 4,300, mainly because the debris cover glacier have long tongue, means because of their stones and rocks, all these things. So they start from the lower elevation, while the clean ice glaciers, they are the smaller glaciers or hanging glaciers, they start from the higher altitude, and they terminate at the some point at around 6,000. So there are different aspects of the glacier. So north facing glacier, so number of glaciers mainly in the north and south facing, while the area is equal in the east west and southwest direction. So they are means well distributed in different slopes. So why there is a large difference in the glacier numbers with the other inventories or other existing data sets for Himalaya? So we have taken three from our inventories from RGI, from Gamdam and ICMO. This is prepared by the Nepal Kathmandu. Gamdam is also from the for high mountain Asian glaciers, and this is RGI is for world glaciers. This is from this consortium from USA, where all the glaciers of the world have been means glacier inventory has been compiled. So we have we when we compare this with our inventory mapped glaciers, so we found that they have mainly, we know that these two glaciers are separate, Satopanth and Bhagirath Khadak, but they have even make them as a single glacier. Mainly they are not able to delineate the glacier ice and the frontal debris cover part. So that's why they have made it they have marked them as a single glacier. So this is the reason we so there another thing here, they have also shown the glaciers. So this is because, so they have the small snow patches, they have also considered. This is the this hanging glacier, this is fine, but they have also marked the this snow patch as a glacier. So that's why there is a difference. And then they have considered this avalanche cones, and they cannot they were not able to even clearly separate this ice divides. So because of the ice, there is a ridge, so ice which is coming in one valley and coming down in the another valley, there is a separate glaciers. So that's why they are not able to to clearly distinguish these things here. So these are the problems that are mainly needed uh, to map the glaciers accurately and to reduce the glacier means area means to reduce the errors in the glacialized area. So uh,
As we are in pitch, so what do you suggest people have?
at how much time do you
So she confirmed the class is better.
okay.
Continue.
So we found that after comparing this thing, all these three inventories, so this GSI inventory is not available in the digitized form, so we cannot compare. Just taken it from their numbers from table. So it is found that the problem is with small glaciers. So they have mapped 128 glacier, 245 glaciers, 169. To 14, and whereas there are we found that there are 106 glaciers. So there are large numbers in their inventory because they have taken snow into the consideration. While in GSI, because they have used topographic map and that is available on 1,000 1 is to 50,000 scale, so that there is no chance to map such glaciers smaller than the 0.5 kilometers square. So that's why they miss this kind of glaciers. Water. So the I think so there is no problem with the large glaciers. Numbers are almost same, but due to this mapping or mapping combining these glaciers, they have taken them as a 8, whereas we have mapped 10. So this is the problem we have found. That so mainly the small patches, and they are not able to distinguish snow and ice, and their mapping method is also problematic. One thing, they have mapped with the help of they have done automatic mapping without having any field experience or field data. So we have done it manually and consider also the field studies around Satopan means 2 glaciers. So this improve our this mapping how the glacier area can be improved.
So there is class.
Yeah.
You have some more slides you can continue on another slot also.
Okay. I think I will come. I will conclude in 5 minutes. We have. Do we have?
Yeah, okay. Please,
Okay. So now the glaciers of this basin are retreating very are at a rate of about 11 meter per year. So the rate of retreat is very heterogeneous from 5 to about 25 meter per year. So there is no means uniformity with size. They are randomly this retreating. So the retreat rate have increased even thrice for this glacier for like this glacier, but there are more or less continue for both time. So that, and this is the same case with the area change. Area change is the highly heterogeneous, and this respond to the also over the long period to the climatic conditions. So the area, smaller glaciers are losing their area at a faster rate as compared to the larger one. You can see that this is the fractional. So small about the glaciers which are less than 5 kilometers, they lost 15% their area, while the glaciers which are larger than 10 kilometers square, they lost only 1.3% during the same period from 1994 to 2020. So the according to glacier size, they are losing mass at a also, the Sir glaciers, these mountain glaciers are losing mass because being the smaller in size, they are losing mass at the this area as faster as compared to the compound valley glaciers. So this is the just distribution of these glaciers. They are well distributed. Means the most of the glaciers are area loss is less than 5% overall, but there are the only 4 5 glaciers. They are retreating at a rate of about more than 25%. So maximum retreat rate is about 38% in this valley. So we have also take this climatic parameter for this glacier changes. So there is no consistency means trend in the precipitation. So we have checked this annual temperature. There is so it has increased significantly as compared to the previous decades. So this is one factor, but these are model data, so we cannot rely on this data. So this is for zero point 0.5 by 0.5 grid. So, but this is some estimate you can say, because in the not having any meteorological situation for long term, so this can be served as a basic data. So this is the main factor that there this glacier rate of means variable rate of change in glacier is mainly because of the non-climatic factors. So the size, debris cover, and elevation and aspect are found the most controlling parameter in this basin. While in other basin there may be slope and maximum elevation, or they are also controlling. But in this basin we found that the mainly this glacier size and debris cover are the controlling parameters. So I can discuss, but we have only sort of time. So yes, so this is also the surface thinning we have done for some of the glaciers for the basin, and they are also heterogeneous. So we found that why they are changing at a heterogeneous rate. So we found that the debris cover here in the case of area change, debris is decreasing the rate, while in the case of thinning the glaciers which are covered by debris, they are increasing the thinning rate, mainly because of the some because the debris covered glaciers are have some features like supraglacial ponds and ice cliffs. So these rates are so these features are called thermocross features, and they are enhancing the rates. So on Satopad and Bhagirath glacier, these are continuously increasing. How much time left? So this is the but based on our field studies, we know that the debris retards melting. But this is the point only point data that state that the glacier retard. But if we take the glacier overall surface glacier, so it thinning is there mainly because of these features. So this is the example how this area, these cliffs and ice cliffs and ponds evolve over the time, and then enhance the glacier melting. So this is somehow, and so the problem that I want to do here. This is the some simple microclimatic. So this we know that this are changing parameters are continuously changing. Means non-climatic factor, but these non-climatic are also regulated by the microclimatic conditions. So we don't have any micro this data from the Himalayan glaciers having covered by debris. So mainly the glacier like Chota Sigi, which is less debris covered, they have done some sort of exercise of energy balance. But on the glacier like this Sadopant, which is heavily debris covered about 50% or more than that, so they we don't have that kind of exercise. So how they are affecting the glacier surface melting. So that this is this will improve our understanding in context of this only how the surface melting is increasing. So this is example from Nepal, Himalaya, where they have done this sort of exercise from surface and air temperature above 2 meter with the help of this temperature loggers, and there is clear difference between the surface temperature and the air temperature. So this was the plan to continue. So I think these are the our paper. This is the team our which I'm working, and this is the team here under whom we are working. So this Chintan, and thank you. So,
Thank you. We have time for some questions. Do you have any questions? Yeah, that's a good question. So, like you said, that there is a really large uncertainties and like the parameters were challenging. Very sure, like robust distribution in all the kind of parameters. But at one point you said that you will be doing only for one glacier and same can be implemented for other glaciers. So how do you explain that the catchment area and the length of the glacier and the geological features are different for the glacier?
for yes, but we have taken same criteria, and the this thing not only one criteria this field. So we have also gone through the repetitive images for individual glacier, and the same has been checked in the field from from 2003 or something. So we can come at the point that there is glacier. So just not a single image to map the glacier. So in this large glacier inventories, they have mostly done they have taken only one image for glacier mapping. So we have not done it like this. We have taken temporal images starting from 1968.
Okay, on the basis of
On the basis of temporal images along with the field experience. and some of the images from Google Earth. Of course, these are not available now, but earlier these were available, freely available. So we have also checked the high resolution images can help to great extent.
Any other questions? Gangotri Glacier is named something else.
Sorry.
Because I didn't see Gangotri Glacier.
So,
That's
so
named-
no, Gangotri Glacier is not part of this Upper Alaknanda basin. So that is different basin. So I have not. So Gangotri is not monitored in the field. Yes. So Gangotri has the longest monitoring series in terms of only frontal part, not in the glacier. So I have shown the glaciers where detailed field study have been done with the help of stake networking, means over the glacier. Not Gangotri because of the size. So
the glacier is much larger.
yes. So that's why it is not so that is not possible to cover the glacier for measuring the this stakes or for melting. So it is not possible in general to cover the glaciers. So it's logistically difficult to map means cover this glacier. So that's why they have done only frontal monitoring, and the hydrology means the water coming out from the glacier. They are measuring it.
In the interest of time, we will stop now. If you have any further questions, ask me. I will be available.